Yes, now we will take a few examples. First one, okay, I'll say let sine t divided by pi t has rectangular, we already know this, right? So has a rectangular function from where to where? -1 to +1 as the Fourier transform. This, let's assume that this is given. So let me call this as x of t, and the corresponding Fourier transform is x of j omega. Okay, so find the Fourier transform of first one. So let us take e power plus j3t sine t divided by pi t. Okay, so what will be the Fourier transform of this signal? So how is this looking at? This is looking like, okay, so let me call this one to be x1 of t. Okay, so this is looking like e power j omega naught t x of t. So this fellow will have what as Fourier transform? x1 of j omega, which is equal to how much? X of j omega minus omega naught. But what is omega naught? It is 3. So means what? You have to shift the Fourier transform to the right by how many units? 3 units. So let us plot that. You shift this Fourier transform to the right by 3 units. So how does the plot look? The plot will look like this. Plot not to scale. So if you shift to the right by 3 units, so this fellow should be 2 and this fellow should be 5. Correct? Or you shift to the right by 3 units, so this should be 4. Note that amplitude of the Fourier transform is not going to change. Okay, so similarly I'll take a second example, which is, let's call x2 of t, which is equal to e power minus j4t sine t divided by pi t. So what will be this fellow's Fourier transform? So again, this is looking like shifting in frequency domain property, and hence you will get x2, right? So you will get x2 of j omega to be x of j omega plus omega naught, which is equal to -4, or which is equal to 4. So this is looking like x2 of t is looking like e power minus j omega naught t x of t, and hence it will have x of j omega plus omega naught as the Fourier transform. What is omega naught for us? It is 4. So how do you plot this here? So this is Fourier transform of x of j omega shifted to the left by how many units? 4 units. So if you shift x of j omega to the left by 4 units, you will get -5. This fellow will become -3. Correct? So look at the plot of x of j omega. It is from -1 to +1. Now you shift to the left by 4 units. So that fellow will be from -5 to -3. Okay, right. Now if you add these two fellows, what will happen? Let us take that as a third signal. Okay. Okay, so what is that? We take x3 of t to be equal to, let's say, e power, or I'll take this one. Okay, sine t divided by pi t. Okay, and this fellow is multiplied with, let us say, cos t by 2. Okay, let's assume that you have multiplied this fellow with cos t by 2. So definitely this is looking like what here? This is looking like, yes, modulation property. Why? This is looking like x of t multiplied with cos omega naught t. So what is omega naught? It is 1 by 2, and the scaling factor is not there, and hence we should multiply the Fourier transform with 1 by 2. Okay, so what will be the corresponding Fourier transform? That will be 1 by 2 times x of j omega plus omega naught, which is half, plus x of j omega minus omega naught, which is half. So what is that you have to do? You have to shift the signal, or you have to shift the Fourier transform to the left and right by how many units? half unit, and then you have to add them. Okay, so and then finally multiply with half. Okay, yes, so let us plot the first one, which is x of j omega plus half, means you have to shift the Fourier transform to the left by half unit. So how does the plot look? It looks like this. So this will be from minus 3 by 2 to 1 by 2. So amplitude would be 1, and this fellow should be added with whom? Another rectangular signal whose plot is like this. So you have to shift the Fourier transform to the right by half unit. So this should be minus half, and this is 3 by 2 with amplitude 1. And what is the next step? This, after adding, the whole thing should be multiplied with half. Okay, so that whole thing should be multiplied with half. So if you add these two signals, how does the plot look? The plot look like this, correct? So from minus 3 by 2 to minus half, this is 1. Minus 3 by 2 to minus half, this is 0. So it should be minus 1. So minus 3 by 2 to minus half, this fellow is 1. Next, minus half to plus half, this is 1. Minus half to plus half, this is 1. So definitely amplitude will become twice. So you will get 2, correct? So you will get a rectangle again from minus half to plus half, and then beyond half this fellow is 0, and beyond half this fellow is 1. So finally you will get plus 1. Okay, so that would be the final Fourier transform, but that should be multiplied with whom? With half. So what will happen here? Here you will get half, here you get twice amplitude, but multiplied with half would be 1. So this would be the Fourier transform of this signal, sin t by pi t multiplied with cos t by 2. Okay, so similarly, let us see fourth example. Let's take that to be x4 of t, which is equal to sin t by pi t. Okay, and this fellow is multiplied with sin t by 2. Okay, not cos t by 2, but sin t by 2. So what should be the corresponding Fourier transform? If you remember, so this fellow will have j by 2 because 2 is not there. So this is multiplied with x of j omega plus omega naught, again which is half here, minus x of j omega minus omega naught, again which is half. So let us try to plot this again. So plots are same, right, just like above, but I will redraw it. So shift the Fourier transform to the left by half, so it looks like this. So it is minus 3 by 2 to plus 1 by 2 with amplitude 1, and this fellow will have a Fourier transform from where to where? Minus half to plus 3 by 2 with amplitude 1. Okay, we finally will multiply with j by 2. Now we have to subtract this. So if you subtract this, how does the plot look? So we are subtracting, and let us see how does the plot look. Okay, so from this fellow minus this fellow. Okay, so from minus 3 by 2 to minus half, this fellow is 1. Minus 3 by 2 to minus half, this fellow is 0. So if you subtract again, you will get 1. So this is minus 3 by 2. Let me write this here. Okay, so this is minus half. Next, so from minus half to plus half, what is happening? This fellow is 1. Minus half to plus half, this fellow is 1. So subtraction will give you 0. So from minus half to plus half, this fellow is 0, means at minus half what happened? It should go to 0. Okay, then so from half to 3 by 2, what is this fellow? Okay, I'll write down this half here. Okay, so from half to 3 by 2, this fellow is 0. From half to 3 by this fellow is 0, and this fellow is 1. So 0 minus 1 should be minus 1. So you will get a minus 1 from where to where? From half to 3 by 2. But what happens to the amplitude? That fellow should be multiplied with whom? J by 2. So this amplitude is j by 2. this amplitude is minus j by 2. So let me make it clear again. The plotting of a complex function is not mathematically correct, but as far as engineering is concerned, this is okay, correct? Because complex functions, how do you plot? You cannot plot, but because only j is involved, we can plot. But mathematically, this is not correct. But as far as our engineering is concerned, that's okay for us. Okay, right. So in that way, we can find the Fourier transform of signal which involves shifting in frequency domain property. So just for homework, I will give, this is fifth one, right? Yes, so let me give fifth one, which is similar to previous one, but sine t divided by pi t multiplied with e power j 4t plus sine 3t divided by pi t multiplied with e power minus j 2t. Okay, so go home, or in your home, please try to plot the Fourier transform of the signal. Okay, next sixth one. Okay, so I will say sine 4t divided by pi t. Okay, this fellow is multiplied with cos 2t. What is the corresponding Fourier transform? Similarly, seventh one. Note that all these things are for practice here, so please do the homework. Okay, so sine 2t divided by pi t multiplied with sine 4t. Okay, so definitely it should be easy for you. So if you solve these problems, the shifting in frequency domain property would be handy for you. Okay, so homeworks are important. Solving as many problems as possible, that is also important. Okay.